Welcome to solverfy.
In this problem, we are given that there is a block whose mass is 1 kg and this block is dropped from a height which is zero point 0.4 meters, and this is dropped on a spring whose spring constant is 1960 newtons per meter, and we are required to find out the maximum distance this spring will be compressed. So let's take that as x here, and let's apply energy conservation principle here. So the total energy of this block at the point where this is released, that would be just due to the gravitational potential energy which is given by this expression, and this energy will be converted into elastic potential energy which will be stored in the spring when this is compressed by x, and we will use this expression for getting the elastic potential energy. So by energy conservation, we will just equate them. So mass into acceleration due to gravity multiplied with the height. Height would be zero point 0.4 plus x, and this would be equal to half kx squared. And let's plug in the values. So this implies that 1 into 9.8 into zero point 0.4 plus x will be equal to 1960 over 2 times x squared. So this implies that 9.8 times zero point 0.4 would be 3.92 plus 9.8x. It will be equal to 1960 divided by 2, which is 980x squared. So let's just rearrange this quadratic equation and we would get 980x squared minus 9.8x minus 3.92 equal to 0. And let's just solve this quadratic equation by using quadratic formula, and we would have the value of x as 0.01 or 0. So of course this cannot be 0. So the accepted value of x that we would select here is 0.01 meters, which in terms of centimeter would be 10, and that's the required answer.